Okay, so let's cover Julia basics. So this chapter of our course will focus in the basics of Julia language, syntax, and also functions. So let's cover variable types. In Pumas in Julia, which Pumas uses under the hood, we have mostly 4 types of variables. We have the numeric, and that breakdowns in integers like this one. So x equals 5. If we run this and we run the function type of to get the type of the underlying object that we are calling the function, we see that we get back int64. This means that this is an of type integer with precision of 64 bits. Since we are running Pumas and Julia in a 64-bit system. We also have floats as the other numeric types. These are equivalent to the real numbers. These are floating point numbers. So y here, it's 3.14. And if we also call type of y, we see that y is a float 64. That's a 64-bit precision float. Those are the numeric types, integer and floats. We also have the string. So Julia is awesome. It's a string. We specify string variables using codes. And if we go and take a look in type of my string, we can see that my string is a string. Just be careful that in some languages such as R and Python, you can create my other string. You can also create strings with single quotes. So Julia is awesome. We cannot do that in Julia. You can see that the Pumas coding platform already advises that we have a parsing error here, and if you run this code, you get an error. And the error is character literal contains multiple characters. That's because Ingo codes in Julia is not for strings, but for character values. So my char equals j. Now, if I run this and we do a type of my char, you see that this is a char type. So, and this also supports Unicode. So if it is something like alpha, and you put this, wrap this in single quotes, you get back a Unicode character. So it also supports Unicode. So you cannot use single quotes per strings in Julia. We also have the third one, strings. We also have the booleans. So my bone equals true. And booleans, if you go in type of my bone, you see that it's a Boolean variable. And these are the 4 basic types of variables that we have in Julia. Numerics, which breaks down into integer and floats, strings, careful with the double quotes, and booleans, which are either true or false. We have much more. Julia has a rich type system, but for now, knowing only those 4 types will get you into a lot of places in Pumas and in Julia. Now let's talk about containers. We have just one type of container that we use a lot in Pumas and in Julia, which is a vector, and the arrays. We specify arrays by creating them with the brackets. So this is a vector, so 1, 2, 3. And if I go in and do type of this, we see that this is a vector of a certain type. And whenever you see those curly brackets here, you should be aware that this is a container type. So vector is a container type that holds types of elements of type int64. So this is the type of this vector here. And you can see that this is just an alias, a nickname, a shorthand notation for array of a certain type with dimensionality equals 1. So this is the one-dimension array, which is a vector. To vector, it's just a nickname for an array of certain type with dimensionality equals 1. And we can instantiate vector like this, so by xvec. And also we can call vectors of anything we want. So this is a vector of string. So here you see that the element of the vector is a string. The type of the elements of the vector are string. And we can also do arrays. So arrays, we don't use commas, we use spaces, and this creates a row vector, which in computing terms is just a matrix with one row. So type of this, it's a matrix of int64 as elements types. And as you imagine, this is also an alias, a nickname, a shorthand notation for an array of type int64 with dimensionality equals 2. So a two-dimensional array is a matrix. And we can also add more rows using the semicolon. So this creates a matrix that has as the first row these numbers and as the second row this number. So this will create a two row by 3 column matrix. So a 2 by 3 matrix. And that's exactly what we got here. We got a 2 by 3 matrix, and this is the first row and the second row. That's how we create arrays. Arrays are mutable. So if we want to change my xvec, this original vector here in the line 13, if I want to change the second element to 42, I can do that. So now if we call back again xvec, you see that the second element is 42. So arrays, either vector or matrices or any other dimensionality array higher than 2, I'm mutable. I can change the underlying elements. I can also do the same with matrix. I can change a single element. So the first row and the second column will now become 42. And if I do this and I call my X matrix again, you see that my first row, second column indeed change it to the number 42. We can also do this column here to specify that all, the first dimension, so all rows. So I want to select all rows, just the first column, and change this to this vector. So this is just the first column of the X matrix, and I want to change that to this vector here. Now, if we do this and call back our X matrix again, we see that indeed our first column, which was the vector 1, 4, brought replaced by the vector 55 and 56. So these are arrays. We also have a second container that we use a lot. These are the tuples. And we specify tuples not using the brackets, but the parentheses. So here I'm creating an X tuple, and if I do type of my X tuple, you see that we have the container here with the wiggle, with the curly brackets, and this is a tuple container, and this is the elements type of the elements of the tuple. So it's a tuple that has 3 elements. The first element is an integer. The second element is also an int64, and the third element is also an int64. Now, tuples are immutable. So if I want to change a tuple, I get an error. And the error is there is no method matching stat index for tuples. So this means when you do this bracket thing notation into a container, this Julia under the hood calls the stat index bank function. So this is Julia saying to you that, okay, I cannot change the underlying elements of a tuple. Tuples are immutable. So these are tuples. We can also specify named tuples because tuples are not so convenient. So suppose I do user options. So the first element is Jose, then the name. Second element is age. Third element is the location. So if I do this, and it is similar to our list. So this is very similar for if I run the this command in R, list, and these things. Now, if I want to recall those things, those user options, I have to go and recover the one. And I have to keep ordering of the options. So I have to remember that the first option, the first element is the name, the second element is the age, the third element is a location. And that is cumbersome for both the developer and the user, because the user has to specify all of those in the right ordering, and the developer has to make sure that he's retrieving the right one in the right order. So that's why we have named tuples. So named tuples is similar to named lists in R. So this is what a named list looks like in R. Named tuples, it's similar to tuples. We use the brackets, the parentheses as the constructors, but we use a semicolon and then we add the key and the value. So in the name tuple, I have a value called age, a named field called age, which value 34, a name field location, which value Brazil, and a name field name, which value Jose. And you see that I changed the ordering here, and the ordering doesn't matter because I can recover those with the dot notation. So if I go name a tuple options and I hit dot and I do some tab to autocomplete, you see that I get back all of the underlying field names that I can get back. So if I want to get back the name, I get back the name. So this is very convenient for the developer and for the user. And as you imagine, main tuples, they are immutable. So if I need to change a name, I don't know, let's call Joseph. I cannot do so. I get the same error as the tuple error when I try to set values in a tuple. So if you need to change a tuple, you cannot do it. You need to re-instantiate it again. You need to create another tuple with given values.